Logic gates, the basis for computer thinking. Hi, my name is Sebastián Palacios, and today I will be showing you and make you understand how these logic gates work, at least the easy ones. So a logic gate is two inputs that go into a system, and then that system outputs an answer. Usually it's zeros and ones, so activation and deactivation. Three of the most popular ones, and the ones we're going to be doing, are going to be first, and, or, and not. The materials that we'll be needing to build any one of these logic gates are going to be one LED, two NPN transistors, two buttons, 220 ohm resistor. You can use higher resistance. It's just for the LEDs not to burn. Jumper cables, a power supply module. You can also use an Arduino, but you know, it's just simpler to use this. And we're not going to be using the Arduino capabilities. It's just, we just need the 5 volts from here. A 9-volt battery, it's, you know, that's a 9 volt, that's too much. So we're going to use a less voltage. And the breadboard. And can be defined as the two of the inputs that it receives have to be activated in order for the output to be positive as well. So two ones or two buttons pressed make the output activate. The second one is OR. So if we also have two buttons, either one of them that I press is gonna activate the system. Okay? Doesn't matter which one, or if you press both, it's gonna work the same. And not, the most simple of all. It just requires one button. And whenever I press this button, the system deactivates. And when I lift my finger so I stop pushing it, it makes the system turn on. So it's opposite. One of the important components that we'll be using in this system is this, the transistor. What this thing does is that in this little connector, it's gonna be receiving the voltage. This is the positive, okay? And it's called collector. The names of these 3 pins are collector, base, and emitter. If you look at the bottom, you can see that the bottom is flat. Whenever you look at this from the flat side, the one on your left is gonna be the positive. The one in the middle is gonna be the base, and the other one, the emitter. So what this does is that the collector is gonna receive most of the voltage, and it's gonna stop there, okay? Because it needs the base, the middle, to receive a little bit of power, so every bit of the voltage that is applied goes through, okay? So this is very important. This is very important because we're gonna be using buttons connecting the collector to the base. Why did I do this? Because there was voltage in that same row. And what this button does is simply to let power go through it, okay? So now, if we make that the power that the collector is receiving, so it goes through the base as well, it's gonna activate this. And then it's gonna let all of the power that it's receiving through. This is important. We will be first doing the AND gate. First, we place the breadboard in the table, and then on top of it, place the 2 buttons. Next, we're gonna be taking out the 220 ohm resistor connecting the positive side to the left pin of a button. Next, the transistor with the collector to the left pin of the button and the base to the right one. The other one as well. Next, the LED with the positive connecting to the emitter of the right transistor. Then connecting the emitter of the left transistor to the collector of the right one. And lastly, grounding the right side of the LED, the negative one. Next, just place the power supply and connect it with the battery. Now we test it. If we press one button, it doesn't work, but with two, it does. Yeah. Next up is the OR gate. First, we're also gonna be connecting the buttons to the breadboard. Next, the transistors, in the same way we did with the AND gate. Don't forget the resistor. The next thing is to connect a jumper cable to both of the collectors, as well as one to connect both of the emitters. What this does is that when either of them are pressed, they're both gonna get the same source of voltage without relying on the other one having to be turned on for the voltage to pass through it. Next, just plug in the battery and check. Either one is pressed, it turns on. For NOT, it's a little bit different because we're gonna be just using one button. But we're also using the transistor in the same position we did before. Same with the resistor, connecting it to the collector. Next, a jumper cable going from the same row of the collector to any other row. We now connect the LED and then we ground the LED. Now from the transistor side, we connect the emitter to the ground as well. What this makes is that whenever I press the button, the voltage is gonna go through the transistor instead of going the way of the LED. And that's it. Now you know how AND, OR, and NOT logic gates work and how to make them. Thank you for watching, and I'll see you in the next video. I hope. If not, it's okay as well. I mean, it's not like if I tell you like you're gonna do it, like you're free to do your stuff, and